All right, so learning goals, we're going to apply properties of circles and ellipses to go between a graph and an algebraic formula. And hopefully you'll be able to determine the characteristics of a conic from its standard form representation. In other words, you should be able to look at the formula after this lesson and determine if it's one of the conic sections that I've showed you thus far. So the creation of an ellipse, there's this fun little activity you can do in class, but it's prone to a lot of error, takes a lot of time. So I just made a little video of it and we can watch this. So imagine you had a piece of string fixed in this way and the pencil could kind of slide around the string. You know what I mean? You see how the result would be an ellipse. That might help you understand the definition of an ellipse. Try not to be too loud by my technical prowess, you guys. OC, original content. Thanks. So ellipses and circles, which isn't a circle really a special case of an ellipse, is what I've always said. It's just a case where the focal length is the same as the vertices. All right, so what is an ellipse? A set of all points, which we're going to call from now on the locus, to help you understand. The locus such that the sum of the distances from 2 points, which are the foci, is a constant. So that if I took the distance from those 2 points, it would always be the same value if I added it together. Call that an ellipse. And as I said, some of the mathematics I teach you is a little bit challenging to find applications for. Not the case for an ellipse. Ellipse models all sorts of things in nature. Primarily the motion of celestial bodies. Like the Earth goes around the sun. It's an ellipse. It's almost circular. Not quite. So that's an ellipse. You now know the parabola and the ellipse. So let's talk about some formulas. So there's one formula for an ellipse. However, the major axis is going to be which of these is larger. So you've got x minus h squared over a squared plus y minus k squared over b squared equals 1. And it could be stretched out along the x like this you see here. Stretched out along the y is also possible. And it depends on which of these two is bigger. If a squared is bigger, it's stretched out along the x. And actually a and b often alternate. Whichever one is bigger is the a. You see what I mean? So if the a were here, it would be stretched out along the y-axis. So whichever has the larger denominator of these two terms, that determines the orientation of the ellipse. So the bigger denominator means whatever variable is in the numerator is the axis on which the ellipse is stretched out, the long axis, which we call the major axis. So the major axis is 2a in length. Now notice this is a squared. So I have to take the square root of that denominator to find a. And then 2 times that value is this length. So starting from the center, it's a units this way, a units that way. Now, if I take the square root of the smaller denominator, that gives me the minor axis, which is 2b in length, and it terminates on what we call the co-vertices. Now, when I give you a test question on this, I'm going to task you with finding the center, the foci, vertices, and the co-vertices. So that's going to be your task, to find all these things associated with a certain ellipse. So the foci are C units from the center along the major axis. The vertices are A units from the center, and whatever the direction of the major axis is. In this case, it's along the X. And the co-vertices are B units along the minor axis, depending on which axis is the minor. In this case, it's the Y. Does that make sense to you guys? You know, that's a lot of information. Kind of a dense slide right here. Probably the most important slide of the day. Sure you're squared away on this before we continue. Or the rest of it will sound like Charlie Brown teacher. Do I ever sound like that? Maybe you're watching a TikTok under your desk. Not a lot of that goes on in no, I move pretty quick. Got to challenge you, smarty pants. Okay, so in your book, the same information is given and some additional formulas that are pretty important. All this logically follows from what I just said, but if you need to see the formulas, let's see, they'll be on. Probably should take the time to write the page on all these slides and save myself this trouble. There we go. Page 433 is where you'll find all this information. You also have that document I shared with you attached to yesterday's assignment, which is all the formulas in one concise list. Feel free to print that out, and you know, I'm thinking like an old person. Maybe just bookmark it so you can access it quickly. My dad's printer, when he was alive, was constantly malfunctioning because he would basically try to print the internet. You know, he's like, Chad, I just got this printer 3 days ago and it's not working. I'm like, yeah, Dad, you printed 500 pages.
When you just start printing just random things, kind of
yeah, like a meme he liked, you know, just whatever he encountered, print. According to him. Okay, so let's graph an ellipse, and it's important to know which one is the A. In this case, do you see how the bigger of the two denominators is under the X? So that tells me, wow, I want to act right. That tells me that the X is the orientation of the major axis. So because this is bigger, so in other words, 9 is greater than 4, and so we have a horizontal major. So the A squared is under the X in this case. And then in this case over here, I know that 4 is less than 9, and so we have a vertical minor axis. So we got a horizontal major axis, a vertical minor axis. This formula to determine C, which is the focal length, is very important, and it's different for ellipses and hyperbola. It looks the same, very similar. In fact, the only thing different is this is a plus symbol for hyperbola, but this is the one for ellipse. So make a mental note that this varies by conic. You can't just use the ellipse formula for all of them. It will not work. So the formula to find the focal length is different for the different conics. So remember to use the ones associated with the conic in question. In fact, if I were you, I would block out all the other ones. If I'm working on ellipses, I would block out all the other formulas somehow, just to keep your brain from locking in on the wrong formula and making a tragic mistake. Okay, so let's find A, B, and C, which should be our first task here. We're already in standard form, so we don't have to worry about any algebra. So A squared equals 9, and A equals 3. We just take the positive root, the primary root in every case. And then B squared is 4, and so B equals 2. And then C squared equals A squared minus B squared, so C squared equals 9 minus 4. So that's going to be 5. So C equals radical 5. So I now know A, B, and C. I know I've got a horizontal major, a a vertical minor. That's everything I need to know. All there is to know about this. So as I told you, the four things you need to know about this ellipse are the center. So that's just going to be HK. And then the foci. So, you know, we've got a horizontal major. So the X value is what's going to vary here. And so it's going to be H plus or minus C, our focal length, comma K. And then our vertices, once again, will major or vary along the major axis, but it's H plus or minus A this time. And then finally, the co-vertices, which are going to be H comma K plus or minus B. So HK, we can do the same thing we did yesterday. See how that's going to be -2 and +1. Stop me if you're confused by that. This period had a lot of trouble yesterday with this analysis. And I'm treating it like an afterthought, but if you're confused by it, make sure to let me know. Okay. And so our C value is square root of 5, so this is going to be -2 plus or minus the square root of 5, comma 1. And then the vertices are going to be -2 plus or minus 3, comma 1. And then the coverts are going to be -2, comma 1 plus or minus 2, like so. So if you can find all that, you can get 100 on that, or 100% on those questions on the test. Well, in older versions of the test, Colby, I always challenge kids also to graph the ellipse, but that was impractical in the Google Forms format. So, well, one thing to be careful about is, you know, I just couldn't put an answer for every possible step in the rationalization of the denominator and so on. So, you know, like if you've got square root of 48, that's not a good simplified expression. You have to factor out the perfect square, which is 16, and it's actually 4 on the square root of 3. So if you had an answer that involved, for example, a square root of 48, you would have to reduce that radical, or rationalize that denominator, whatever was necessary to get it to a fully simplified state, and then compare it to my answer set. So that's something to be cautious about. But yes, this is the way I set up the answers. And I'm going to make a quiz that's in the same format for tomorrow, because I don't want to just voice that new format on you at the end of the week having never seen it. I think the quiz would be a good chance for you to kind of see what my plans are, you know, for that particular assessment. Because it's a different kind of, it's a checkbox. You know, so what you've got on that test, you've got this list. And then you've got a series of answers up here. You know, let's just say. And then you've got boxes. And you just check the right box. You see what I'm saying?
Oh, okay.
Yeah, so it should be actually more straightforward than the tests I've given on this in the past, but time will tell. We'll see. You gotta hit that jewel pipe every morning. Like, didn't you pee when you got up? You know what I'm saying? Like, how you had to pee in 10 minutes?
I only do whenever I like drink coffee and then I come to school.
Even then, that's got to percolate for a minute. You know what I'm saying? All right, so let's plot our points here. -2, +1 is there. And then that's the center. So we'll just label that with a little c. And then I've got -2 plus or minus the square root of 5. Now, the square root of 5 is 2 point something. So we'll just go 2 and then some change. So this is -2 minus, so that's 2 and change, +1. Go 2 and change this way. And that'll be focus 1 and focus 2. And then the vertices, -2 plus or minus 3. So here we go, 3 units from, so that's V1, V2. And my focus 2 is going to be in the way of, wow, you just don't want to shrink, do you, son? But you're going to. And now the co-vertices. So we go to -2 to the center, +1, and then we go up 2 and down 2. And then we'll connect those co-vertices and vertices with a smooth curve. That looks like a potato, but that's, art was never my strong suit. Have a mind for practical matters.
Art. So you graph everything from the center?
Indeed, yeah, the center's sort of your, it's not part of the ellipse, but it's a point of consideration when finding all the other aspects of the ellipse. Good observation. Any other thoughts, comments? Nobody? Okay, cool. All right. Anybody need to see any other aspect of this problem? Notice the algebra is just absolutely minimal if it's already in standard form. But like I said yesterday, sometimes it's in standard form and sometimes it's not. And when it's not, you have to do some extra work. So here's an example of an ellipse that's not in standard form. Now, if it's in this format, it's kind of difficult to tell parabola, ellipse, whatever. But one way to know is if both of these are squared and both of them have the same sign, then you're dealing with an ellipse. So we want to algebraically manipulate this expression and get it to this. And I'm assuming the major axis is the A. It might not be, but we can make that distinction when we get there. So we want to make it look something like this, and the A and the B might be in the wrong place, but we want it to look like this. So this is our goal. And the way we're going to do it is just this big old nasty template I'm going to make. So I'm going to take everything involved with X and add a blank there at the end to complete the square. And then I'm going to take everything involved with the Y and add a blank. Then I'm going to shift the constant value to the other side of the equation and add another blank for balancing the equation. Now this is going to be tricky. You see this 4? I told you I wouldn't throw you one like that on the test. Well, I'm holding to that, but it's okay for homework. It just makes our lives a lot more challenging when we have a coefficient like this. So I got to factor out that 4 first of all. Makes that a 6x. Then nothing to factor out over here, so. Now we're ready to complete both squares. When we balance this equation, we got to be real careful. Is this 4? So 1/2 of 6 squared is 9. So I added 9 here, but do you see how I really added 9 times 4 to the left side? So I need to consider 36, the value that will balance. But I still have to complete this square, so we'll wait and do that simultaneously. So we added 36 and 25. So that's 61 to balance the equation. $61 balances. So this value would probably be where a lot of people get derailed because they wouldn't consider 9 times 4. They would just add 9. They would add 34 right here. So if I saw that, I would instantly know you didn't consider this aspect. Be cautious about that. Now, in both cases, because we have completed the square, we now have a perfect square trinomial, a PST, which is super easy to factor. So let's rewrite those two as 4 times x plus 3 squared plus y minus 5 squared equals 64. We're close. You see how we're getting closer to this? Now I need this right side to be a 1. You see how dividing through by 64 would accomplish that task. So the 64 is also 4 times 16. So if those 4's cancel, that denominator becomes 16. And there we go. We have achieved standard form. Now notice in this case, the y is the major axis. The bigger denominator is under the y in this case. So here I see, because 64 is greater than 16, this is going to have a vertical major. Now be careful because that scrambles a lot of things up when compared to the previous problem. And because 16 is less than 64, it's going to have a horizontal minor. And so let's find, and remember also that c squared equals a squared minus b squared for ellipses, not the same for hyperbola. Okay, so a squared is 64 and a is 8. So b squared is 16 and b is 4. C squared equals 64 minus 16. And so C, I want to skip a step. C squared equals 48. So C is radical 48, which is radical 16 times radical 3, or 4 on the square root of 3. So you need to factor out all perfect squares from the radicand of an expression in the radicand. So factor out all the perfect squares here. In this case, 16 is a perfect square. It is also a factor of 48. So I factor that out. I'm left with 3. 16 times 3 is 48. And then the square root of 16 is 4. And then radical 3 is fully reduced. There are no more perfect square factors for 3, of course. So this process can prevent you from getting this problem right on the test, because my answers are going to look like this. They're not going to look like this. Now, if you want to take the time to convert everything to decimals, you can sort of beat the system that way. But what a tedious exercise. So if I were you guys, I would master this skill if you haven't already. Okay, so now let's find all our values. First of all, the center. Remember that that's just HK, which in this case is -3, +5. And then the foci, which in this case are going to vary along the y. That's different from last time because, I'm sorry, not A, C. C is a focal length. So varies along the Y because we have a vertical major. So both the foci and the vertices are going to be along that major axis. So that's -3, 5, plus or minus 4 on the square root of 3. Now in Google Forms, the way I had to write this bit is like that. Just so you guys will know what you're looking at. This is how I had to write it in Google Forms. It didn't give me the option for the symbol. And it's not really clear what the radicand is, the way the ASCII radical is, because it doesn't have a top bar. You know, it's just that part. And what's the radicand, what's not. I'd have to use parentheses, and it would be, in effect, more confusing, I think, than this. So I just did it this way. Now let's talk about the vertices. And that's going to be H, K plus or minus A. And that's -3, 5, plus or minus 8. Yep. And then the co-vertices. So that's going to be H plus or minus B, K, which is -3 plus or minus 4, 5. Now we're going to have some points off the graph in this case. Let me show you guys a cool tool here. Oh, so your calculator won't graph this well. We would have to do that funky algebraic business where we solve for y and then we have a plus minus and we graph it in two different expressions. So, you know, your calculator can give you some kind of approximation, but a better way to do it, if you would just want to check your answers and you're at home on your home computer, is through Wolfram Alpha. So you can just make this little template. And then I'll put blanks in for those. And then you'll just plug in H, K, A squared, B squared, whatever. So in this case, -3 and 5. So that's going to make that plus 3. And 5. And then this was 16. And this was 64. This will give you a pretty good little graph. Now they want you to get the paid version, so they don't let you copy and paste, but you can always kind of beat the system with the Windows snip tool. You know what I'm saying? Oink. You think you're going to get $1.99 out of me? Wrong. That'll buy me 2 things at the Dollar Tree. Okay, so questions about anything you see here? Thoughts or comments? All right, good. So those are, in effect, the 2 kind of questions you'll see on the test about ellipses. One, where the square is already completed. It's in standard form. You just got to determine the points. That one should be a gimme. One where you got to do a little work completing the square. And in the case of ellipses and hyperbola, this part is unavoidable. So again, I'm not going to throw you one like this on a parabola, not on an ellipse or a hyperbola. This part has to be there. So you will have this step in those 2 cases. All right, so let's see here. All right, so here's one for you. I want you to try to find all the characteristics and then sketch me a graph of this ellipse. It's going to take you several minutes. Just work diligently for me. Best way to cultivate this skill is to do it yourself. Math is not a spectator sport. you can watch and get good at. Gotta do it. Well, these two are inextricably tied. There we go. You know, if you get confused, mixed up. Maybe you get too geeked out on energy drinks. For the next step. One should be one. Have two is one squared is one.
So, on this one, or this one, just the one times nine.
Yeah, 1 times 9, and then also plus 25, so 34. And that's good. That should give you a total of 81. And, you know, when constructing these problems, it's kind of important that this be a perfect square to make it easy. So it makes sense for it to be 81. You see what I mean? That's 9 times 9. That would be a good way for you to know you're on the right track. Not always, I don't guarantee that, but that's just a good rule of thumb. If you encounter perfect squares, you're probably doing something right. As much as you complete the square of it. Well, both these answers are right, but we have to add 34, because 1 times 9 is also a plus 25. That's number 34. Add on At least you got tomorrow off. Well, distance. You'll have a quiz in this class.
Are we having a meeting tomorrow?
Having a what?
Meeting?
No, I don't know how productive it is. I may, if enough people express interest in it. This is right. Yeah, this is very good job. So you're gonna want it at 80. You did a good job. Yeah. One little bit. So you did classic. So it's not just one. So that should be good. Everything else. What you do next is you find your perfect square. So this. Is plus 1.
And notice that, and that's what they yeah, and the reason inside the parentheses, that's what that's what goes down. It's B over 2, basically. So it's the part that you squared. I'll tell you that. Now you need to know everything I do, which is this representation.
So now that we know.
Okay, so that's 1 times 9. All this is right. 1 times 9 is 9. That's 25. It's 34. So 34 is what that is.
On this one.
Well, so what I would do in the times on is to say vertical. That's already correct. That's 9 and a horizontal plus 1.
And these are the equations. The first two are off the back.
The value that
So the second one is vertical measure. The first two are K and the third one. So it has like an inverse HK. For the one at the end, it'll be H times K plus just C. So on. So A.
This is no factor. See, this is negative. So that's going to be y minus 1 plus squared. That's going to be 81. Which is this plus that. Now, not everything that I do
K plus minus.
so 9 goes into A1 9 times. So the next step that also is this is the same. This term becomes
H plus minus.
Okay, yes, question?
That's okay. Just about second. How'd you get this?
That's the only problem.
Well, you're
Like I don't have
so, no, it's okay. The only thing is that is no, these nine we cancel. So the next step, that should be. So, A is 9, and that's the D down. So X plus 1 squared is 9.
So that's just.
But you get that next step. And this is still 81. And so now from there, it's just like the other.
Excuse me. It's okay. Guys, I'm gonna put the answers up here. You compare what you got. And, let's see here. I'm gonna make it big enough to read.
The A is 9.
C is 6. Use 36 and 2 for the rest of the
Okay, I saw it. I was.
Yes.
Oh.
Yeah, so C is the square root of 72, and then 36 times 2. So I kind of skipped a step right there, which I often do if I'm just working a problem, but if it's for public consumption, I try not to do that.
So on that exact step, you always want to choose the
biggest perfect square, yes. Because if you choose a smaller one, you got to do it again anyway. So you're just doubling your work. So choose the biggest perfect square factor, and then see if if you choose the biggest one, you'll fully reduce it every time in one step. Okay, so questions about this process. If you can get this one right, there's nothing holding you back from making 100 on the Chapter 7 test, which some of you need, like the desert needs rain. Okay, so equation given characteristics. So you remember before we did one of these problems where you have, before we had the formula and then we developed the characteristics. Here they give us a couple characteristics and we must infer the formula. So we got to be like Sherlock Holmes here. We got to investigate. We got to use our evidence to find our equation. So the major axis here. So that is, notice it varies on the x. So the x values are the ones that are different. So that tells me it has a horizontal major. Which means the bigger denominator is going to be under the x, just from looking at these two values. And I also know that this is going to be h plus or minus a, comma k. So I've got kind of a little system of equations here to solve. First of all, I see that k equals -2. That's no problem. But then h plus a is going to be the bigger of these two, and so that's 5. And h minus a is going to be the lesser of these two, and so that's -1. I've got a little set of equations here to solve. And I could use matrices if you want to get kind of crazy, but I could also use substitution. So that would give me -1 plus a equals 5. So -1 plus 2a equals 5. 2a equals 6, and a equals 3. So I just care about a. Because once I get a, h is going to be obvious. So if h minus a is -1, then h minus 3 equals -1. Add 3 to each side, and h equals 2. Okay, so we've got now h, k, and a. All we need is b. And we've got this bad boy flipped. So that's going to come from this minor axis situation. Now notice these vary along the y because it has a vertical minor. If you get a horizontal major, you got to have a vertical minor. If I flip a coin and I say it's not heads, it's got to be tails, right? You got a binary choice here. In other words, 2 ways you can go. And this fixes this. So here I see that this is going to be h comma k plus or minus b. So I've got k plus b is going to be the greater of these two, which is 0. And k minus b is going to be the lesser of these two, which is -4. Now I know k already, so I don't have to go through the systems. I just pick one of these and plug in -2 plus b equals 0, so b equals 2. And there we go, everything we need. So horizontal major, h is 2, a is 3, so a squared is 9. And then the k is -2, so that's going to be that. B is 4, or b is 2, so b squared is 4. There's our answer. Okay, questions about anything? All right, so while talking to you guys and thinking about it, how many of you guys would like to do a little homework session tomorrow? I'm good with me. Okay. All right, so we'll work something out, something maybe that not everybody has to attend, if the interest is minimal. That's okay. Hopefully that just means you fully understand it based on my lecture. Hopefully. So we're gonna skip this one. We don't need another one of those. So the concept of eccentricity, this will also be a test question. It measures the roundness or out of roundness of an ellipse. So how unround is it? You see what I mean? So the eccentricity is going to be E equals C over A. So how does C compare to A? So we're so E equals 1 is a circle, so it's perfectly round. And as you get closer to 1, you have a rounder ellipse. Do you see what I mean? So as this ratio, and it can't get greater than 1 or you get a hyperbola. So as it would be less than 1 for an ellipse, greater than 1 for a hyperbola. E equals 1 means it's a perfectly round ellipse or circle. But C over A, and remember, you got to fully reduce. So the test question I created does require you to rationalize and so on. Reduce the radical. And also, here's a little tip for you and a bonus for people that watch the video. The ellipse I used for this problem is the same as the one I used for one of the other problems. So you don't have to do the work again to find C and A. Just refer to that other problem. It'll take you like 2 seconds. Bonus for attentive students. So let's determine the eccentricity. Remember that E equals C over A. So we need to find C and A. Here I see that A is the square root of 64, or 8, and C squared is going to equal A squared minus B squared, which is 64 minus 36. And so that's 58, 38, is that right? No, 28. Double checking myself here. So that'd be 58, 28, yes. And so C is going to be radical 28. That's not fully reduced, is it? Got a perfect square factor. What's my perfect square factor here, Rowdy?
9.
Not quite. 9 goes in 27, but not 28. Think smaller.
6.
And 6 isn't a perfect square. It is a factor. And that's a common mistake. Well, it's not actually a factor, but you might have values that are non-perfect squares that are factors. But we only care about this list. So that is those are the only things we want to factor out. We don't care about any other value, just the perfect squares.
25.
So that 25 doesn't divide it evenly. Think about this now. You see how 4 times 7 is 28?
Mm-hmm.
So that means it divides it evenly, and it will reduce our radical. So you got to be able to go from here to here. Yeah, Wolfram Alpha can do it for you, but come on, are you that boring? Challenge yourself. Okay, so now we're ready. We got A and we got C. So this is 2 on the square root of 7 over 8. That's not what you would see on the list of answers, though, because it's still not fully reduced. Because 2 goes into 2 once and into 8 4 times. Radical 7 over 4 is what you would see. And if we want to know a decimal approximation to know the roundness of this ellipse, that can be some good information. So 0.66 That's a fairly oblong ellipse. You notice how this value is not really super close to 1. So that's a pretty round ellipse, football shaped. All right, questions about anything? Okay. So the orbit of planets is fairly circular in the inner solar system. But as you get out there, they become more eccentric. In fact, so eccentric that Pluto and Neptune often change places as the furthest from the sun. Now, Pluto's not really a planet anymore, but if you include Pluto as a planet, they change places as the most distant object from the sun over the course of their elliptical orbit because it's not round. They go further out, closer, further out, closer. And in the case of comets, you've got an extremely elliptical orbit. So this asks us to find some information about Uranus. So the eccentricity of the orbit of Uranus is 0.47. In other words, it's a really oblong, football-shaped orbital path. The orbit around the sun has a major axis length of 38.36 AU, astronomical unit. Who can tell me what an astronomical unit is? Be impressed. Most unfortunate. It's the distance from Earth to the sun. So sorry to tell you, that little solar system you made in 4th grade was not accurate. Because you didn't have 38 times the length between the Earth and the sun, and then also the Earth and those outer bodies. So it's a lot further out there than you think, than you could possibly represent. It's a long way, even between Mars and Jupiter. It's an immense distance. Because Jupiter is a big old, massive object, and it swept up all that matter that would have become intermediate planets. And there's an asteroid belt between those two bodies. But it was never able to coalesce into a planet in the way the other matter in our solar system was because Jupiter's gravity is just too great. It's almost a star. Imagine that. We almost had 2 stars in our sky. Almost. If Jupiter were double its current mass, it would probably be a black dwarf. So anyway, what is the length of the minor axis? So if we have E, so what do we know? We know E equals C over A, and that's 0.47. And we know A equals 38.36. So that means C over 38.36 equals 0.47. So I multiply both sides by 38.36 here to get 18.0292. And then I know that C squared equals A squared minus B squared. So 18.0292 squared equals 38.36 squared minus B squared. So solving this for B, I get this. So what I did, subtracted this 38.36 squared and then multiplied both sides by -1. You get that? So we take the square root of that mess to get B. So that's going to be negative . So let's find out. This would be the closest this planet comes to the sun. So this is the furthest. You see how A would be just as far away as it gets? But this B value would be the closest it gets to the sun. Important information for us to know. How many astronomical units is it at its closest? So let's see. Square root negative 18.0292 38.0292 squared minus 38.36 squared. So 33.85. And let's go 86. So about 33.86. If I use the same number of significant digits we did in this previous step, so not a whole lot of difference, is there? But enough to make it a pretty elliptical orbital path by comparison, because Earth is almost perfectly circular. Almost. You really have to have some sophisticated instruments to determine the eccentricity of Earth's orbit being other than 1. Because it really looks like 1, but it's not. It's ever so slightly elliptical. All right. Let's talk about circles. So the standard form of equation for a circle is x minus h squared plus y minus k squared equals r squared, where the center is h comma k and the radius is r. If you miss this one on the test, shame on you. This should be a gimme in both cases. So I got 2 circle questions. Should both be gimmies for you guys. I think you have a question. Okay. So, just came up with one challenge. So let's say probably best to use one from your text. All right, so let's do x minus 3 squared plus y squared equals 4. From this, can we find its center, its radius, and then sketch its graph? So remember the formula. So tell me what the center is in this case, Mason. Very good. 3, 0. And tell me what the radius is. Square root of what, Rachel? Okay. Think about this relationship. Well, if r squared is 4, then the radius is the square root of 4. So it's just whatever is here, once you're in standard form. Now, if you got some constants floating around over here, you've got to take care of that first. But once you're in standard form, it's just whatever is to the right of the equal sign. It goes under that radical. And then, of course, this reduces to 2. So that's a circle. And then to graph these is really simple. So we go to 3, 0, and then you go this many units north, south, east, west. So up 2, down 2, right 2, left 2. Connect with a smooth curve the best you can. Drawing a circle is a challenge. Leonardo da Vinci was kind of persona non grata in his home of Italy back in the Middle Ages because, well, he sort of bucked the system. The Catholic Church ran everything at that time in his part of the world, and he was a flamboyantly gay man. And they had this little snitch box on the door of the church where you could snitch out your neighbors. You know, I saw Joe Blow spit on the sidewalk on Sunday, and then the church would punish you for that. So people kept putting notes in there, like, I saw Leonardo holding a boy's hand. You know, so he got snitched out frequently. The church didn't really love him, in other words, for that. But he's applying for a position, the official artist of the Catholic Church. Well, that's like, you know, a huge deal in this time. The Catholic Church is the biggest organization on the planet. So he's like applying to be the premier artist on the planet, in spite of what the church saw as flaws. And so for his interview, Pope handed him a sheet of paper and said, impress me. So Leonardo drew a perfect circle, handed it back. The Pope was thusly impressed, and Leonardo got the job. Leonardo da Vinci, I'm not, but I do my best. Let's think of another one. Let's see here. One that we need to modify. Let's see. So if I've got, let's see, x squared plus 5x we'll do that. So we need to complete the square. Let's rewrite this. Use this little template. So, not a great example because that's going to be a fraction. Let me reconsider. Make our life easier here. So, 4x has a coefficient of 4. If I divide that by 2, that's 2. And if I square it, coincidentally, I wind right back up at 4. And then 1/2 of 2 is 1. Squared is 1. So 1 completes my square here. So if I add 5 to the left, got to add 5 to the right. Now I can move to standard form. X plus 2 squared plus y plus 1 squared equals 28. So my center is what, Jan?
It would be 2.
Think carefully. X minus h, y minus k.
Oh, negative 2, negative.
Very good. You're perilously close to losing a syllable from your name. The Jam started out as James. Every time he made a mistake in class, I reduced his name by 1 syllable. Eventually, he'll just be. So radical 28 is our radius, and then if we reduce it as we did earlier, we get 2 on square 7. All right. So that was everything I wanted to teach you. We learned about ellipses. There's 2 different flavors. They can go this way or they can go that way. We learned about eccentricity, the roundness or out of roundness of an ellipse. We learned that Uranus is eccentric. The important thing to know. And then we learned about circles. So hopefully all that's squared away in your head. Your challenge is to complete page 438, 3, 4, 9, 10, and 31. Best of luck to you, ladies and gentlemen.
How do